Hello everyone and welcome. In this video we are talking about the SSC Tuatara World Record Run, and of course there's some controversy surrounding this run, so that's what we're going to get into. There's three questions I'd like to answer. First of all, what do we know? Second of all, based on the video, how fast do I think the car actually went? And then third, based on the specifications of the car, how fast is this car actually capable of going? And so to start figuring out all of this information, I spoke with many of the parties involved. So I spoke with Jerod Shelby of SSC, who was very helpful in providing information. I spoke with Dewetron, the GPS company that was used to see how fast the car was actually going. I spoke with Driven Studios, the video production company filming all of this. I spoke with Webb, the driver of the top speed run. And I spoke with Tim, aka Shmee, who was like, hold on a minute, when he started looking at the video footage and some things seemed a little bit off. So what do we know? Well, based on a press release by SSC on October 19th, on October 10th is when this run was done. And it was done on Nevada State Road 160, and there were 3 total runs done. So one run was done in the southeast direction towards Las Vegas, where they hit a top speed of 287 miles per hour. One run was done, they set up everything, they do it then the reverse direction, and another run was done in the northwest direction at 301 miles per hour towards Pahrump, and then they did one final run, so they set up again and did it the reverse direction, southeast towards Las Vegas, and they hit a top speed of 331 miles per hour. So those were the only 3 runs done, and those are the top speeds associated with it. So then on 10/19, if you average 301 and 331, both of these in opposite directions to validate the average speed of 316 miles per hour. So that was the claim. Top Gear put out the video showing them hitting that 331, that final run. So then on October 26th, Shmee goes, hold on, wait a minute, some of this isn't adding up, because what he noticed is if you look at the medians and you measure the distance between the medians using Google Maps, you can see that the car starts at one median at 192 miles per hour, and then by the time it gets to that second median, it's traveling at 307 miles per hour. And that takes about 22.5 seconds. So if you take 1.13 miles and divide it by 22.5 seconds, it gives you an average speed of 180 miles per hour. Now 180 miles per hour is lower than its speed during that entire run. There was never a time where it was traveling less than 192. Therefore, that's impossible. Something doesn't add up, right? This cannot all happen. Now, I like Shmee's method there. I think that's a very simple way of explaining it. You know, you can't have an average speed that's below the speed you're traveling the whole time. That doesn't make any sense. So anyways, on October 26th, SSC puts out a statement and they said, Dewetron, a globally respected GPS data measurement manufacturer, has validated SSC North America's claim that its Tuatara hypercar had averaged a top speed run of 316.11 miles per hour. Now, I asked Dewetron if they did in fact validate the speed of 316 miles per hour, and they said no, they did not. And on October 28th, Dewetron put out a statement saying Dewetron did not validate any data from world record attempts or preceding tests. They also went on to say that the results of measurement data highly rely on the right setup. Now, also on October 28th, SSC puts out a statement and they said, the good news, we did it and the numbers are indeed on our side. They go on to say somehow there was a mix-up on the editing side, and then they go on to say that Driven Studios does have extensive footage of everything that transpired and is working with SSC to release the actual footage in its simplest form. We'll share that as soon as it's available. Now, obviously there's some confusion here, right? Because one of them is saying, hey, they validated the claim, Dewetron saying, no, we didn't validate that claim. So I reached out to Dewetron to kind of get some clarification, and some of the things they provided to me were that Dewetron equipment is calibrated and tested before being shipped from our factory, and they said that due to Corona, presumably the virus, but it would be funny if it was the beer, due to Corona, we provided a virtual training to SSC for basic setup and configuration in early 2020. They went on to say, yes, Dewetron verified that the equipment was verified and accurate. Dewetron equipment leaves our factory always tested and verified by qualified engineers. And they go on to say, we were not involved in the setup or configuration of the runs. Okay, so finally on October 30th, Jerod Shelby puts out a video on their YouTube channel and says, "We were concerned there were doubts in the relationship between the video and the GPS, that this is always going to have a stain on it, and that they have to rerun the record." So I'm excited and happy to hear that they are going to, try and do this again to make sure everything is done right and actually achieve the record. And I have one more email which we will get onto later on in this video, but that is what we know. That's essentially what we know. So now, personally, I have two questions when looking at this video footage. First of all, is it possible that the video is the third run? The video that we see, is it possible that that's actually the third run? And also, is it possible that the GPS and the video, the GPS data displayed on that video and the video are of the same run? So that's the question I'm trying to figure out. And I think it is possible, yes, to both of those questions. Reason being, okay, so is it possible that the video is the third run? Well, there's only two runs in this direction, so the video could only be from one of these two runs. And you can look on the laptop at 1:15 in the video, and it says 319 miles per hour, 513 kilometers per hour. This does convert to that, so that makes sense that that's what the video is showing. And so the video is showing on the laptop of the run, not the GPS data overlay. The laptop is showing 319 miles per hour, and we know the first run's top speed was 287, so it couldn't be the video from the first run. And also, Oliver told me that he only celebrated on that final run. And so Oliver celebrates in the video. So to me, that says, yes, it is possible that this third run is the one being represented in this video. Now, is it possible that the GPS data overlay matches the video? And I think yes is the answer to that question, that it is possible. There are 5 gear shifts, and there's about a 1 second delay in the GPS data as it kind of drops speed a little bit after each of those 5 gear shifts, which tells me the gear shifts line up. That seems to make sense that the GPS data overlay would then be correct in matching this video. Maybe it's slightly off time-wise, but that it matches this video. Also, you can look at timestamps at about 27 seconds, 36 seconds, and 1 minute 15 seconds. And you can see on the laptop the speed displayed, and then you can see the data overlay about 1 second later will show that speed that you saw on the laptop. So you can see that correlation. And then finally, there's a video uploaded by the channel Creator Up, who I believe is responsible for doing the 360 video for this run. They have the full 360 video posted, and so you can see very clearly the laptop with its display matching the GPS data overlay. So they're off by, a slight timing difference, but you can see that they correlate, that the whole time as he goes through that run, the laptop is showing a very similar speed to what the data overlay is showing. Okay, so now, as the whiteboard implies, we're going to do some dumb calculus. And this isn't a dig at what some journalists think about YouTubers. This is genuinely going to be dumb calculus. This is a dumb way of doing calculus, but it's a way that's very easy to understand, which is why I'm doing it this way. So really all we're going to be doing is just multiplying two numbers together. It's very simple. So what we're looking at here is a plot. We've got time on our x-axis, we've got speed on our y-axis. So we're just looking at the SSC speed from the very first median that it reaches to the second median that it reaches, because we know the distance based on Google Maps is about 1.13 miles between those two medians. So we're looking at the speed that it's going. And so what we can do is we can try and figure out, well, how far did it actually drive? And so we can split this up into little chunks of time. So for example, right here, we're just going to take 1 second of time and see how far it traveled. So we know that it's starting this at about 193 miles per hour. We say, okay, it travels at 193 miles per hour for 1 second. So you multiply velocity by time, that gives you distance. So 193 miles per hour times 1 second times 1 hour is equal to 3,600 seconds. And what that gives you is a distance of 0.05 miles. So 0.05 miles. So this little chunk right here is just going to be 0.05 miles. And so next, after 1 second, then it's traveling a little bit faster. And we can look for that next second, okay, how far does it travel this time? And then we can add up each of these little rectangles all the way till we get to our final time. So we have 22.5 seconds. So I'm going to do 22 rectangles plus half of one rectangle and add all that up to see how far did this thing actually drive. And again, this is the dumb way of doing calculus, because really you want to look at every single point on this curve, so you're not leaving out this little extra space. But I'm choosing to use the speed before that second, not at the speed the end of that second, which means we're going to leave a little extra distance on the table. That's fine. We're not super concerned about it. This is just going to give us a conservative estimate of how far did this thing travel. So you add up each of those boxes based on the video footage, the data overlay, and the fact that it took 22.5 seconds. And what do you get? You get a distance of 1.54 miles. Now, the interesting thing, you can do the exact same thing because Koenigsegg ran their Agera RS on this same road between these same two medians. You can do the exact same math to figure out, okay, well, what did the Koenigsegg do? So we know based on Google Maps that distance is 1.3 miles. Based on some dumb calculus, we're saying the SSC probably had to travel at least 1.54 miles. And so what if you plug in Koenigsegg numbers where it gets at that first median at 226 miles per hour, it gets to the second median at 264 miles per hour in 16.5 seconds. So you add up 16.5 little blocks like this, and you get a number of 1.12 miles. So near perfectly with the Koenigsegg data, and we're off by a significant amount with the SSC data. So if we take this 1.54 and divide it by 1.13, we get a correction factor of 1.36. So for example, that would mean if we were traveling at 243 miles per hour and we multiplied 243 by 1.36, that would give us our top speed of 331 miles per hour. So the correction factor is implying that if the speedometer were to read 331 miles per hour, the actual speed it would be traveling at is 243 miles per hour, assuming that video is correct. Now we have a third median, so we can run this same analysis again. The difference here is that we are starting at what we left off at, so 307 miles per hour. We're then reaching 331 miles per hour, and then we're coming down to 239 miles per hour in about 25.2 seconds. So that's the number of blocks we're going to add up. And a Google Maps estimated distance of 1.42 miles. So that's what we're looking at for the SSC, and the numbers that I get for that, how far did the SSC actually travel when I add up all of these blocks, because I'm a dumb, internet kid just adding up my little blocks and seeing what happens. And so we get 2.08 miles, and that gives us a correction factor of 1.46. And so if you were to look at, okay, if our top speed shows 331 miles per hour, we divide that by our correction factor of 1.46, that gives you an actual top speed of around 226 miles per hour, again, assuming that the video is accurate. Now, what happens if you take the Koenigsegg video and do the same thing? It enters at 264 miles per hour, 19 seconds later, so 19 of these blocks we're adding up, we get to 271 miles per hour, and theirs comes out to, the math comes out to 1.42 miles. So I'll, of course, display on the screen the Excel spreadsheet where I have all of this shown of, what's the math behind all of this, so you can see the actual addition of these blocks. But the Koenigsegg data lines up with the video, and the Shelby data shows that a correction factor, could be applied to explain why the GPS speed seems so different from the visual speed. Now, the smart thing to do with all of this, and what I was hoping someone would do, because I'm lazy and I don't want to take the time to analyze every single frame, is to analyze every single frame and use much smaller blocks and then add those up, and that would give you a more accurate estimate. Well, luckily, Julian Thomas of Race Logic, the dudes that make this great VBox equipment, luckily he went in and did that. So we looked at it frame by frame, and he came up with a correction factor of 1.48, giving you a top speed of about 224 miles per hour. Now that lines up with my second analysis. This one's much more conservative and saying, a speed maybe of 243 miles per hour. But either way, it looks like, a correction factor could explain why we see a difference in speed. Okay, so this correction factor or this scaling factor to me seemed like just the easiest, simplest explanation. Like, could it be possible that there was a correction factor somehow in the software, in the setup, and as a result the numbers were off simply because within the setup, somewhere in there, there was a correction factor being applied? And so I asked Dewetron if that was actually possible within their software, and what Dewetron said in an email on October 31st, Dewetron oxygen measurement software comes with a strong math and advanced math functionality. Theoretically, it's possible to scale and filter any input values. So in theory, it is possible to have a correction factor within the setup, and that could explain why these numbers were off. Now, Dewetron went on to say, I'm not saying that SSC engineers have done that, and personally, I believe that the car can run a record speed, and we will support SSC in another run. Great. So this leads to our final question. Because the car is going to rerun the record attempt, what is its theoretical top speed? And so in order to figure this out, this is a power equation. So power is equal to force times velocity. Now, force in this case is our resistive forces of the car. So we need to consider the drivetrain efficiency, we need to consider aerodynamic drag, and we need to consider the drag from rolling resistance. So that's what we have set up here. We have power multiplied by our drivetrain efficiency, and then we have the equations for the force of aerodynamics and the force of rolling resistance, and then all of that is multiplied by our velocity. So you plug in the numbers based on SSC specifications, and they provided me some additional numbers like the frontal area and the rolling resistance coefficient for the tires, and you get a calculated, theoretically possible maximum velocity of 345 miles per hour. So this is a very powerful car, and according to the specifications, very aerodynamic as well. So its theoretical top speed is quite high. Now you might be wondering, Jason, is your math correct here? Does this all make sense? And so my verification of that is, well, what if I run the same analysis on the Koenigsegg Agera RS? So this vehicle has 1,000 kilowatts, about 400 horsepower less than the Tuatara. It has a higher drag coefficient with more downforce, and it has a larger frontal area. Now, it was able to achieve the average in both directions, a top speed of 278 miles per hour. And if I do the same math analysis, just like this one right here, there's one small assumption on downforce, but downforce isn't going to play a huge role in the rolling resistance. But if I run that same analysis, I get a calculated theoretical top speed of about 282 miles per hour. And that's very close to the actual speed that they tested. And you can kind of see in the video, it's kind of cresting that, 271 in that run that we were talking about earlier. It's kind of just sitting there at 271. It's, struggling to accelerate much more there because it's getting very close to its theoretical top speed. So I think it's capable, based on the specifications, of definitely going over 300 miles per hour. Okay, so that spot right there is probably the cleanest place to end this video. However, unfortunately, I feel like there are still some unanswered questions as a result of gearing. Now, the thing that I don't like about gearing is that unless the car finishes its run and I pull out the differential and count the teeth on the input and the output, I'm not going to know what that actual gear ratio is in the car. It's very difficult to know that. You could possibly back calculate it using CAN data, which I'm trying to look into, but basically what I'm saying is it's very difficult to know gearing information. Now, there are two gear packages offered with the SSC Tuatara. There's a high downforce gearing package, and there's a highest velocity package, a VMAX package, where you're trying to reach that maximum top speed. And so the gearing for them is different for gears 6, 7, and the final drive. And so if you look at the high velocity version, the version going for the maximum top speed, 6 gears 0.757, final drive ratio is 2.92, and if I do the math, that works out to a top speed in 6th gear of 336 miles per hour. And so in a statement, SSC is saying that if you look at the data log, the car is at 8,600 RPM in 6th gear during that run, which puts it very close to 331 miles per hour. Now suddenly you have a discrepancy now between the gearing data and the GPS data if the video is accurate. So it could be that this CAN data can validate this GPS data if they both line up. However, there's also a different gearing package, a high downforce gearing package, where the 6th gear ratio is 0.784 and the final drive ratio is 3.454. And so if you look at these numbers, that gives you a maximum speed in 6th gear of 274 miles per hour. Now, based on an analysis by Robert Mischel and Misha, where they're looking at sound frequencies, they believe different gearing was used, this high downforce gearing, that 0.784, rather than this 0.757. So to me, this leaves two final questions, which I'm still trying to figure out. Is the CAN data available to verify the gearing? And then also, is it possible that there was just simply a mess up in the correction factor in the settings for the Dewetron GPS system that could explain why the GPS and the video do not match? Okay, well, very conveniently, after I had finished filming this video, I was able to hop on the phone with Jerod Shelby of SSC and discuss my remaining few questions. And so regarding the CAN data being available in order to verify what gearing was used, and this is actually referenced in their press release that they do have a data log. However, they will not be releasing this data. They also do have additional footage of the run that has been sent to them from the video production company. However, they will not be, SSC will not be releasing this video footage. At this point, basically everything is going towards the second attempt, making sure everything is done 100% correctly so that it can all make sense. And finally, this question of, is it possible that there was a scaling setting that had occurred with the GPS settings? So unfortunately, apparently, I am told there is no GPS data. So I'm told the only GPS data that exists is a screen recording of the laptop screen that's displaying the GPS output from the run. And so I'm told that this screen recording is what is needed to submit for the world record. However, to me, obviously, it does seem strange that for something so critical, you wouldn't actually record all of the data from the GPS. But at this point, everything is focusing on redoing this, making sure all the T's are crossed and the I's are dotted, and making sure it's done correctly. My math, based on their specifications, looking at a top speed of 345 miles per hour. I did tell this to Jerod Shelby and was like, hey, what do you think? Is this close? And he wouldn't tell me what their internal guesstimate calculation theoretical max speed was, but he did say that I was close. So it'll be interesting to see what happens with the second run. Thank you all so much for watching. If you have any questions or comments, of course, feel free to leave them below.